We are now live. Cool, but maybe we can start with just quick updates from folks and go from there. So Joe and Thibaut, you were front and center on my screen. Would you like to start?
Go ahead, Thibaut. Just writing.
Cool, Joe.
Like, oh, it's very terse.
So let's see. So I've been just trying to keep up on some of those pull requests and try to nudge people in a few directions and ask some questions and get things pulled in properly. Especially trying to nudge people about writing tests for things they've added.
And how, if you ever need support with nudges, feel free to ping a few of us and we can definitely help you out there.
Other than that, I've been going through the 2.5D DC code. So since Doug has gotten back, I'm sure he can update you guys a decent amount on my Myanmar stuff. So maybe I can talk a little bit more about some of the things I'm seeing in the 2.5D code after that.
Yeah, that sounds good. I will add that to the Perfect. John, do you have any updates you'd like to?
Nothing really. I kind of been picking up a new processing code kind of stuff for our new surveys, but I'm going to be working. We got some clients that want 2D stuff, and I remember you talking about we can kind of assume that with the 3D code, we could do something there. I might bug you guys here in a bit, like next week. That and the A inverse matrix is symmetric, so you don't need them both. But other than that, that's all I got.
That's great, John, and that is actually something that throughout the code base we can try and streamline for the EM side of things. So for those who weren't here last week, John's been looking at some efficiency things with mostly, is this the MT code where you've primarily been? Yeah,
just mostly the MT recently here, just trying to speed it up a bit, but you speed it up and you gotta use more more RAM kind of thing.
Yeah, so he was looking at storing some of the matrix factorizations, and right now throughout the code we work with A and A transpose when we're doing the adjoint, but because it's symmetric we don't actually need to do, we don't need to refactor. And so that's something that we're doing in a lot of places that we could streamline.
Yeah, I can take a look into more of that for sure in the coming weeks.
Thanks, John. Cool. Hey, Colton. Welcome.
Hey, everyone. Yeah, thank you. Sorry I'm late.
No worries. How are things going with you?
Pretty good. I'm back to modeling stuff in SimPEG.
Excellent. And how are things going?
Not terribly. I've been having a lot of fun with different ways of creating models and transferring them to a mesh. That's really where I've been spending some time, just because that should be easy. Building meshes shouldn't be the hard part, so to speak, in my eyes.
Excellent. That will definitely be valuable. I know that Dom has done a fair bit with the octrees, but having utilities and stuff built out is going to be super valuable. That's awesome. Cool. And Doug, you're back from Myanmar.
We are. Yes. We had an adventure. I think this would be you could call this a SimPEG adventure, because we plan to do a lot of our teaching and instructing around using Jupyter notebooks, if you've heard of those. And use my binder and install Anaconda. And then you find out that maybe if they actually had Wi-Fi, it would be helpful. So we had a few challenges, but in the end, we actually were pretty successful. And I'm so impressed with the ability for us to present material and to teach people by using these apps. And you know, the whole group, and Soggy in particular, you know, really deserves to be complimented on this, because you could just see how the learning could come about, even though, you know, the basic mathematical understanding or, you know, any kind of technical material could not really be understood, because their mathematics level was actually much lower than we had anticipated. So yeah, there was a number of apps. I guess there's probably 6 or 7 there now that are available. And yeah, we used the, people were really involved. I mean, I think that was the thing. It just really got engaged with the material. So I think that this whole set of material, the slides and the apps that are being put together, we need a little bit of refurbishment just to kind of really tidy them up. But I think this is going to be just a wonderful resource that can be used, you know, virtually everywhere. So the, you know, the 1D, you know, the parametric, and then the 1D smooth, and then we've got the 2D, 2.5D code. So we've been making use of that. Yeah, it's slow, but it seems to be giving results that are comparable to Res 2D, which is the Loki's code, and also the DCIP 2D UBC. And we want to do some more testing just to make sure, you know, that we're getting the right results out from these codes. But yeah, aside from the fact that it's slow, it actually seems to be working pretty well. And I've talked to Joe, and Joe, you know, spent an evening just taking a look through and did some profiling. He talked about a bit more, but he found a number of places that looked like they could be speeded up. So, John, I was going to ask you, have you used the 2D code or the 2.5D code? Because you were just talking about wanting to run that. Oh,
I was doing it for the, or going to be needing it to do for the MT, but I have touched in on the DC a bit. But yeah, not overly to go in and kind of see where to speed up things though.
But did you use the 2D the 2D inversion notebook that Soggy put together, or?
Unfortunately, I haven't yet. I didn't get around to it.
Okay. Yeah. That's fine. I was just wondering, because I think eventually, well, not eventually, soon, we're actually going to have to employ the 3D because, you know, even though we just had lines of data, sometimes the lines got a bit crooked. You know, you run into a road and you need to take a detour, or in one case it was just curving around. So we'll have the opportunity to look at potential 3D effects. Okay. I think in the end it's going to make some really nice case studies, and as we try to get through this, you know, more intensively, it's a perfect opportunity to decide, you know, where we can speed things up so that both the 2D and the 3D code are optimally.
Nice. Yeah, I've got a lot of Jupyter notebooks already for like forward modeling within the company here, or within DS. So I could talk with Soggy and see if we can make him fancy like he's got the 2D stuff.
Well,
oh, sorry, Doug. You.
Okay.
Oh.
No, I lost you there for a sec. So what were you saying? You had you said you had Jupyter notebook.
Yeah, I've got a bunch of 3D Jupyter notebooks on simple forward modeling that I've distributed throughout DS.
Okay.
And they're not fancy though, how Soggy's made it, so I can maybe talk to him and we can see how we can maybe spice them up a bit.
Oh, well, that's great. It would be nice to kind of find out what you've got, and then yeah, I guess the other thing that maybe kind of comes up with this is maybe where to put these notebooks so that they can be shared. Actually, Lindsay, the reason I kind of bring that up at this point, it's a bit tangential, but Alison Malcolm was here, and she's been using some of the notebooks that we had for the GPG, and she's further developed them. and asking, how we should share them, or what a good way of doing that is. Just a second.
Yeah, that's a good point, and perhaps a good segue even to, I dropped a link for the education discourse. So got an email, and some of you who are on Slack would have seen that Graham Heinzen joined Slack, and he sent an email saying he's extremely enthusiastic about using SimPEG for his courses. So that, I think, a couple thoughts is, like, I think, again, a bit of impetus for us to get the simulation stuff in pretty quick. So I'm totally happy to help push on that in probably a couple of weeks' time, if that's helpful, or if, like, I know that Joe has been motoring, so that's great, because I know that branch includes a ton of documentation, updates, and tutorials, so that'll be helpful for onboarding other people. Yeah, but so we started the education discourse, and there's a couple posts in there. Deequan's posted, and Graham has posted. So if anyone wants to chime in on those conversations, that would be great. I think, so the way, and this may or may not be the most effective way to move forwards, and this is something we should think through. The way that the GeoSci stuff kind of works right now is we've got, at least for EM and for the GPG, is we have basically a notebook warehouse, that's the GeoSci labs. And then for each course, you basically just copy paste a subset of those notebooks and import the GeoSci labs code. And then you can sort of tailor your course to include whatever subset is appropriate. So if that model seems to be working, we can certainly continue with that. But if not, we can rethink things a bit. I know that, for example, Leo started a repository or an organization, I think called like the Geophysics Library or something like that. And the goal with that was to be much more like smaller scoped things. So each repository was basically a single notebook, plus an environment file and whatever, maybe like a README with sort of some of the learning goals and things like that. So that actually sort of goes to the other extreme. So I don't know where we want to be sitting with all of that, because yeah, we've kind of got notebooks all over the place. So maybe actually even the thing to do is if we start with a discourse that just like documents, first of all, what we have, and then go from there and figure out how we should parse things out. From your conversation with Allison, Doug, were there like, did you have any ideas of what we should be doing?
No, it was really a matter of a question, because she said, well, she'd taken one of the one that you might remember, and she said she wanted to fix it up, whatever that was, and she's got that, and I said, well, can you share that with us? And she said, sure. And then she said, how do we want to do this? And that's just sort of led to the conversation that we had talked about a number of times a long time ago, but I think it's raised its head now, both with Allison and also with John. I mean, so, everybody's getting these notebooks, and, it'd just be nice to somehow make them so that you kind of know where they are and that they're shareable, and decide on maybe tidying some of them up, and just really going to that next step of having better code or better notebooks, and in places where we know where they are.
Yeah, I mean, so maybe like a first thing that would be great is if Allison could post on the GeoSci Labs GitHub repository and say that, hey, she's made some updates. And if she's comfortable, she can make a pull request. If she's not comfortable with GitHub, then we can talk about how to actually incorporate her stuff, either like sitting down and having a phone call with her and just walking through that, or we could do something via Dropbox or whatever. But yeah, I think just getting a sense of like which notebooks did she change, and then we can move forward on that trajectory, and then figure out sort of a broader mechanism for moving forward.
Okay, and then, yeah, so that's good. So she's taken one of our notebooks and made changes and improvements. So, you know, transferring it back to doing a pull request by GitHub, that sounds good. Now, what do we do about John, who's sitting there and he said he's got a number of notebooks for the 3D DC resistivity, and you know we're going to be using the 3D. Soggy has definitely got notebooks, but now John's got something. How do we kind of communicate and decide what we really want to further develop and have general, or what parts are just like, okay, that's for me, that's my notebook, and we don't really need to worry too much about upgrading or sharing it.
Yeah, I mean, so maybe we need to think through, like, I like the way that we've set up the SimPEG research GitHub organization, is anybody can create their own repository, and then it's just like, here's some stuff that I did that goes either with a publication or it's just a scratch space, like that's fine. We could maybe think, I think we would need a bit more structure and scoping for like a GeoSci style thing, is sort of looking at who's the intended audience, I think matters. Because the GeoSci lab stuff right now is very much just like, here is a notebook that's an app. And that's great, and that serves a specific audience. But for 3D inversion, we may or may not want to turn the entire thing into like a widgetized notebook. Like, that might not actually be the best way for users to get familiar with the code and to interact. If they're doing something that's 3D, I think it's in some senses fair to assume that like they can maybe punch in a line of code to like type out the file name and things like that. And so that might make more sense as just like a very nicely structured notebook with maybe a few widgets in there for like exploring the inversion results and stuff like that. I don't know, but I think that those things like perhaps have different scopes. So I wonder if we want to start like, if that would either be a new SimPEG repository or a new GeoSci repository, just around, for example, DC resistivity. And we could just have like a collection of notebooks that work through, like example notebooks that work through DC resistivity. Yeah.
I think that's something for all of us to think about, because it's the perfect timing, right? It's just, some of these things have just converged from a whole bunch of different directions. And actually, I'll let people know another thing that is related to this, and that is the whole concept of using case histories as the real glue for the use of any of these DC resistivity, well, or any kind of survey. So what we found in Myanmar, we go right from the very, whoops, are you still there?
Yeah, we're still here.
Am I still here? Okay. If we go right from the very beginning of any kind of project and just start the case history, just open up that Google Doc and type in the stuff for your setup and what whatever map you've got or something like that, and just to really use that case history format as a guide to assessing how you are progressing, and for other people to get some idea about where you are in that. And then what we've been really concerned with Myanmar is to make sure that everything is reproducible, so that within the case history, we actually have the raw data file, or at least you've got access to the raw data file. And then any code that is used to do the processing of that, to get rid of bad points or anything like that, all of that is documented. So that means that somebody else can come through and discard the same points that you did and know exactly what was done. And then for the inversions, like in using any of the the SimPEG codes, again, all of the parameters are there, whatever your mesh was, and it's just all documented actually inside the the case history, and then you've got a final result.
And when you say like so reproducible and documenting the processing steps and things like that, is that documented like is that in a notebook? Like, can I re-execute the exact same thing, or are you talking about documenting in words?
No, so that you could redo the exact same thing.
So
right?
like, do I have, they've got a notebook that like I could pick up and work with? Is that the idea?
That's right. They actually, it's a separate program for in this case. It's one that comes with the Syscal system.
Yeah.
But it's freely available, and then there's some filterings that's done, and those are captured so that somebody else could start with the raw data and get their own copy of this process and have enough information that decide, okay, what's the data set that I'm going to invert. And within a Dropbox file, we also have those process data, so somebody could just start from there and then carry through and do the. So I think this really has hit home to me as far as something that's extremely important. I mean, we talked about this a lot, but to actually see how it can work is, there was a new revelation. And some people, you might be interested as to what was actually going on in Myanmar. And that is that DC resistivity soundings have been traditionally used there. And there's been something like 5,000 soundings done over the last, 10 or 15 years. They're basically all Schlumberger soundings. So each sounding is done by the national DRD. So this is the group in the capital. And there's a guy there who is head of the irrigation department. And he is responsible for those surveys and the interpretations. So they use a code, which is called IX1D, which is a parametric layered Earth model code that you put in your sounding data and you get resistivities and thicknesses back from that. Okay, so there's really only one person who knows that code properly, and it's this guy, and he is the director of irrigation. He's like way high up in there, and then he runs the code, or sometimes he has a couple of people kind of running code before him, and then he takes the results of that and he makes the final interpretation of like whether there's a potential aquifer up here or there. And that is all encoded then on a single piece that shows the resistivity structure and his interpretation. That is then sent down to the state level. They see this single piece of paper and then they decide to drill. At the state level, they have no idea how that model was generated. All they have is like, okay, here's a resistivity model, and we're supposed to find an aquifer at this depth. So that's just about as extreme an end member of geophysical surveying and interpretation as I think you can get. And so that concept of just trying to have the data and have whatever analysis you're doing reproducible, I think will be huge for them, and it'd be just great to see that pushed forward.
Yeah, well, let's brainstorm on that with maybe in discourse and like outline some of these pieces, because the SimPEG research GitHub organization might be a good model for how to capture things. and then we can figure out how to display them through a website or something like that. Yeah, that's super cool. I want to give Dom a chance to say hello. Hi, Dom. How's it going?
I don't see Dom.
It's doing all right. I'm doing good.
Oh, there you are.
Hey guys. I had a frustrating and long 2 weeks of trying to run. Speaking of notebooks, having people to run notebooks. I'm a little bit jaded by the whole idea. I'm pretty negative about notebooks this week.
And what were the big sticking points?
Just to get people, set up is already hard enough, and then you need to teach them on top of that another layer of commands, and yeah, just the installation by itself is tricky, and every time, yeah. Anyway, it's just dependencies and all that. I think personally, I think we should not spend not too much energy at all on maintaining notebooks, and we should spend way more time on documentation and making sure that the API runs fast and smoothly, and then let people do their own experiments, because I'm just scared we're going to burn a lot of resources that we have already very little. We have Joe as a resource, and if we spend too much time handling notebooks, we're just going to burn through it, and we're not going to accomplish what we're here to do. That's my opinion.
What notebook were you, Dom? What notebook were you trying to implement? And also another question while we're still on, was it like getting started with downloading Anaconda? Was that a problem at all?
Yeah, all of it. Well, Anaconda is one thing, and then Jupyter. Yeah, and then Jupyter requires Chrome. It doesn't handle other browsers, so you need to set people up with that. And then if you wanna run SimPEG EM1D, you need to make sure that they've compiled SimPEG on Anaconda and not the other one, because it's on pip right now. It's just a nightmare. I was trying to rerun the old Geo toolkit, what I've done with Diane, It's still online, it's still there, so people are still trying to run it. But now the dependencies are broken. It's just, it was a nightmarish week. So, but anyway, that's life.
Yeah. Dom, you saw my comment about the F50 package for toolkit, by the way?
Yeah, I haven't got to that point. Yeah, but thank you. That's good. That's good to know.
Yeah, Dom, I think it's a very fair point that we should, documentation is really the place to be, and examples in the docs are really the place to be investing efforts. I mean, the notebooks make sense for targeted projects, but for really getting folks up and running, the maintenance is for sure non-trivial.
And they're just really hard to version control, right? Like notebooks they're not controlled on Git, so yeah, unless they're inside the documentation and they run inside it and we know if they're working on it when we build the docs. Otherwise, it's just we're gonna spend so much time trying to maintain those notebooks, and I'm not sure how much traction we're actually getting out of it. If we have one person on the notebook, but we spend a week total time maintaining it, I don't know if it's a good investment, basically. I'm just gonna.
And Dom, that's an important point to think through with the workshop. One of the things, so for the SEG, we should think through what the goals of that really are. Because one thing that we could do, if installation is expressively not a goal, then we can launch a Jupyter Hub. And that is something that's actually pretty easy to do if we've got not a huge number of users, as long as the internet is okay with SEG. That's something that we could do. And because if the goal is just to teach people the API, then having them play around in a notebook is nice. But I completely agree that we, yeah, like sort of the maintenance of notebooks as a job of ours is not a great thing to take on.
Yeah, and we don't want to spend, we don't have to waste an hour and a half just having, 10 people in a room install Anaconda and all the dependencies. Like I've done this already 3 times this week, and it's huge waste of time. Like I don't want to have to do it again. Or maybe we just have like, we have a test file, that if you can run this, it says, because I remember that when I did the Python carpentry, the software carpentry, that's what they were asking people to do. If you can run this and it says, okay, you're good, then show up. If it doesn't do it, then email us ahead of time and we'll figure it out. But don't show up without an installation, because it's too much of a waste. We only have a half a day, right, for that workshop. So
I wouldn't rely on internet at SEG, because it's
that's right. Yeah.
It's very rare that there's internet in the areas. I mean, there's internet in the conference hall, but you kind of have to pay for it most of the time. I would not rely on internet access at SEG.
Yeah, that's very true. I remember that too. Yeah, you're right.
Yeah.
So we'll have to come up with a plan.
And like they offer the possibility to ask for it, like a Felix Hermann group asked for that in 2018, and when they showed up for their workshop where they paid for the internet, like there was no internet, no thanks. So it's not reliable.
So what we did in Myanmar, since DRD didn't have internet, fortunately, the students and attendees, everybody had phones, so they just created local hotspots, and that was sort of the way we got around that.
Yeah, because to that point, we might actually be able to get, and I have never looked into this, but I wouldn't be surprised if we could get basically like pay for a cell service that just gives us a big enough hotspot for 30-ish people. Yeah, but these are like, we can brainstorm on this before SEG, because this, yeah, we don't want to be dealing with having folks try and download Anaconda for the workshop. Like,
do you know how much bandwidth is it pulling, the Jupyter Lab? If you have, let's say, one person on Jupyter Lab versus 2, is it like twice as much, or what's the cost?
We can play around with that. I don't know offhand.
Yeah. Because you're streaming a remote, basically like a remote desktop, yeah.
Yeah, but in that case, like what you're sending back and forth isn't actually super heavy. Like you're sending views of, like, basically you're sending code and then sending a view of the data back. You're not actually like delivering. If you ran a 3D inversion, those results sit on the Jupyter file. They don't actually get sent back over. So it shouldn't be anything too crazy.
Right. Yeah, it might be a good idea.
Text information, a few images here and there when you plot images.
So we just ask someone to sponsor a hotspot, like a cell phone with a good internet, and then we just deal with our own network. That is not a bad idea.
Yeah, and I mean, we can ask folks to try and download and install Anaconda, but I would guess that even if we send that out beforehand, if we're lucky, 50% of participants will, but that's unlikely.
I know. Yeah. And then if they show up without it, and then they still want us to help them install things, and we're still going to be wasting time on it. I think we should, hopefully, if we can do it on Jupyter Lab, it's probably a good idea.
Dom, it'd be interesting to, I'll have Devin send you a link to a video that he made for downloading and installing Anaconda for Myanmar. So it'd be great to get your feeling, and anybody else's too. Is just, does that work or not?
Yeah, well, I'm sure it's great. I'm sure it's a good idea to do a video. But the thing is that every machine is different. If someone has ArcGIS installed, not the other one. One has QGIS, not the other one, and then they all conflict with each other. It's never the same. I can tell you, it's never the same.
Okay, fair enough.
Yeah. There's always something that is not foreseen that is happening every time. But that's just what it is.
Yeah.
this comes from people not completely understanding what installations are doing when they're going through it.
Yeah, but I mean, yeah, fair enough. But we can't blame people for not understanding, right? We're not, people are not programmers, so. Yeah,
No, not at all. I'm just saying it's like it's unfortunate that like there's so many other programs out there that kind of don't advertise what they're doing, or if they do, it's
Oh,
or just you know.
fair enough. Fair enough. And otherwise, other than complaining, I will. Joe pinged me to be to do the test for the tile map. So I'm gonna work on this tomorrow because I think it's pretty important to bring this in.
And it doesn't have. It just has just something small.
That touches it. Yeah,
Like
I get it.
it and a small, couple tiles, and that's about it.
No, absolutely. Yeah, we just need to basically to make sure that the sum of sensitivities is the same as the global, and to make sure that the transfer of model property to the local meshes is like also makes sense.
Yeah.
And then, yeah, it's going to be small. Okay. No inversion. We just need to have basically the back and forth mapping working. And other than that, I had more interest to keep working on the mag radiometry yesterday, so I'm probably going to be pushing that next week. And then just more work on exposing SimPEG through the analyst API. So that's what I've been working on at work. It's kind of everything is kind of converging, so that's good for me. Saving time. The Geo toolkit is actually. So Diane, we met again with the guys at Minerva because they really use it heavily for their daily work, but I just don't want to have to maintain import exports anymore. With GeoSci, with GeoSci.xyz, and there's a bunch of requirements that break down. So we might just simplify the whole package and just only do like a few core operations and drop all the input output because it's just too much dependencies.
And Dom, do you think maybe like one way to perhaps gracefully drop that is just like put it in the comment box, or like at least provide some instruction how if somebody wants to do something more advanced, like there's a queue that yes, this is more advanced, but like go look at this package and you can figure it out yourself.
Yeah, that's a good idea. I think we brought those dependencies because we wanted to like very people like newcomers to be able to just straight grab like a GeoSoft grid or an ARC shapefile, but the dependencies are intense, so we can just add comment and say if you wanna get a grid somewhere else and bring it in, that's on you type of thing. I think that's fair.
Yeah, and I mean, as long as you give them a pointer as to how to do that, then what that does is we don't actually drop the maintenance load, we shift it to the more advanced users.
So where would you put this comment in the README or?
In the README or even in the notebook, like where you're reading in an example shapefile or something like that, is basically say to get it into this form, we use these libraries, like check out their docs. Good luck.
That's a good idea. Yeah. I will do that. That's a good idea. That's it for me.
Thanks, John. Okay, so we've just got like 5-ish minutes left. So want to open up if there is a chance, or if there's any sort of high priority items. The thing that I think we should go through, and I'll maybe ask that even if we don't have time to do this now, there's 3 issues that I think Joe has pointed to, and Joe, I'll let you speak to these, that we need to start coming to decisions on for moving forward with the simulation branch. And so it would be great to get input from folks so that we can make a decision on these things. Joe, do you want to?
Basically, what we're talking about is the simulation rename, like having a consistent name for all the simulation objects, simulation classes for each method, and just coming up with a good name, or just thinking about standard deviation and the place. So I feel
Which
like
numbers? What are the issue numbers that you're talking about here?
846 and 847.
Okay, yeah.
So it's standard deviation and it's placed in the code base and renaming a methods problem. I feel like a simpler one to tackle really quick is just the problems, like renaming everything to a consistent simulation. I'm not sure if you guys have read through that, looked at it. I haven't really had too many comments outside of, I think Craig commented and Lindsay. That was about it. I posted both of them to Slack as well last week.
I don't have an opinion. I think if you guys are happy, I mean, I don't have an opinion.
Okay.
Just pick something. I'll be happy.
Okay. I feel like that's a little quicker. I have a feeling everybody's probably got the same kind of opinion. Just like, yeah, pick one and make it consistent and go with it.
Yeah, as long as it's consistent.
Yeah, because like you can definitely tell that it's inconsistent throughout everything right now. It kind of makes it tough to deal with.
So the choices about what the options are, they're sort of listed on the issues, because I haven't really been
Yeah, I can kind of show really quick.
Yeah, go for it.
Sure. Okay. So essentially, right now, like right there's I don't know if you can see my mouse or not, but
yeah.
Right. So it's like, okay, these are the names for all the EM or frequency domain, time domain EM problems. Natural source, it's a little bit different. DC methods, it's a little different again. Potential fields, it's drastically different. Like these are all the same kind of class. They're just different subsets of that class, right? Whatever VRM stuff, it's different again. And for the other two outliers, they're like the Richards and the straight rate seismology thing. Again, it's different. So the idea is we just come up with a consistent naming formulation that we would propagate to all of them. So some of the few options that I put out there. So one is this. I'll start with the idea is we would probably all want them to start with simulation. So you can use like tab completion and search through it, and kind of idea that this is going to be a simulation class. Okay, so simulation, then whatever dimensionality it is, and then some sort of short description about the problem. So for the EF, so for like the electric field, so it's one option would be simulation 3DE for the electric field simulation, simulation 3DB for the magnetic flux density simulation, 3DJ. Another option would be maybe a longer description about the simulation. So instead of E, it would be called electric field or magnetic flux density or cell-centered or integral simulation or something like that. Yeah, mostly it's probably going to be, however, this, it sounds nice to like say it, but it gets to be a really long thing, right? So it's kind of a detractor to that. So those are the kind of things that we've been looking at naming it. I'm not sure.
Okay, no, I have an opinion. I prefer a second choice.
Which one?
The longest one. I don't really care if it's long. People will type completion anyway. So
yeah,
I think the more English, the better it is.
I'll second that for sure too.
I mean, it's always something, right? Like you can always just kind of, import from, from something, import simulation as sim, right? Like
Exactly.
it doesn't quite matter what the name of it is.
I think it's less elitist if we tell people directly what we're talking about than having to assume that they know what J is.
My gut feeling is I would agree with that, because especially if you can then do just what you said, call it whatever you want in your program, and then just have it
Shorthanded. Yeah.
Lengthy description you've got, but something that is very, very specific.
Yeah.
That sounds right.
Yeah, initially I was drawn more towards the short description E, just because that's like the thing that we're actually discretizing. But hearing this, I think that, yeah, that seems pretty reasonable, especially if we're importing it with shorthand, and or I think eventually creating basically a higher level wrapper layer that abstracts this away from the user. Because most users actually like don't care if they're using electric field or magnetic flux density simulation, because they're doing the exact same thing. So we should be abstracting that away from the user. But for us, the clarity, that seems good.
I think that's what I would have. That's what I was originally kind of feeling as well. Just kind of having it cleared out there. So, okay.
I think that dimensionality first is a good idea, because then for when we list, when you do the tab, they're all going to list, you know, all the 3D are going to list first, all the 2D after, and all that, right?
Yeah. Yeah. Okay, I'll probably move forward with something like that.
Just a general question. I haven't really looked into it. Do we actually need to have different classes for the formulations? Can't they just be like a flag in the simulation mag flux? You know? Sorry, in the simulation 3D.
It's actually like,
They're very different.
well, it makes more sense in this case to, sorry, clock is saying it's 2 p.m. here. So in this case, we're basically overwriting the way that like the A matrix is formed for each of those. Each one has a different A matrix.
Okay.
So the class structure is identical. So I think for those ones, the inheritance side of things makes it easier to have them as separate classes.
That's why we were talking about like having some of those generator things too, where it's like if they don't really care what formulation it is, then they shouldn't have to.
Yeah.
But, yeah.
That's great. That was just a general question. Yeah.
Okay. The other one was, I mean, the other one's not as big of a thing, right? The standard deviation one. There's been a little bit more talk on this one and discussion, kind of thoughts going on and things. Not as high a priority, I think, just to kind of get things. I mean, I'd like to have it settled pretty quickly, if possible. But let me go over it. So basically, right now, I'm going to use some of like this formula, kind of in terms of the code, right? Like this is terminology of the code. So there's a standard deviation that gets multiplied by the absolute value of the data. You add a noise floor, and that equals some uncertainty, right? Well, I mean, most of the time we're using uncertainty as the standard deviation of a Gaussian, right? So like, the uncertainty is actually more like the standard deviation. So it kind of doesn't, like, having this here doesn't quite make sense statistically. Like, that's not the name of that quantity, right? So we were talking about kind of possibly renaming that quantity, or just asking. So some of the options for renaming it were either relative error, percent error. I think we kind of know, talking about one of those two. And then Dom brought up something about just, okay, screw it and just have uncertainty, have it be standard deviation, like not worry about either of the two of them, I think. So.
I need to wrap up here. I'm sorry. If folks want to chime in, maybe we can do that on the issue and or Slack, and then make a decision on this one, like either in those two forums or early next week. Is that all right?
Yeah.
Okay. Sorry to cut you off.
No problem.
Okay. Well, see you all next week.
Thanks for organizing again. Bye, Lindsay.
Yeah.
Bye, guys.
Thanks, Lance.
Yeah. Bye.